Well, good evening. Welcome to SOCAN's July monthly meeting. And tonight we're going to hear Alan talking about in cold blood, I can't see this, the global warming guillotine for our buggy friends and foes. And so we'll introduce Alan in just a minute. On behalf of the board and our executive director, who is now in Portland, still part-time with us till the end of the month, but we are looking for a new executive director, and if you know anybody who's interested, the information is on the website, socan.eco. Right in the front, there's a link to the job description if you know anybody who might be interested. So the plan for tonight is Alan will do his presentation, and then I'll do SOCAN updates, things we have going on, and then partner events that we are aware of. But before we start, I'd like to ask you to join me to acknowledge the land that we are on. As an organization based in the Rogue Valley, we gather here on the occupied lands of the Lagawa, Shasta, and Takelma people. In the 1850s, tribes were displaced due to the gold rush and colonization of Southern Oregon. This brought war, starvation, genocide, and the erasure of the local tribes. In 1853, the Rogue River Treaty was signed, where 3 tribes were forced to cede their land of the Upper Rogue Valley and relocate to temporary reservations, the closest one being located at Table Rock. We recognize that we are on stolen land and will work to protect our community, the climate, and environment for future generations. Oregon is home to 9 federally recognized tribes. However, there are many more that do not hold this status. We hope that with this land acknowledgement, you will research the land you reside on, work with us to honor the original caretakers, and to protect our environment and community in the work we are doing. Thank you. We like to start with an opportunity for people to meet other people, hopefully people they don't know. So we pose the questions, what are your favorite local insects or arachnids, which are spiders, right? So we'd like you to identify somebody close to you, hopefully someone you don't know. Introduce yourselves, share your thoughts, and give yourself a minute each to maybe talk about what you know about your favorite insects or arachnids. Okay, go ahead.
I like them all. Like mosquitoes, I don't like them. Whatever spider will eat the mosquitoes is my favorite spider.
I like spiders. I don't like the widow spiders, but you know, butterflies.
Correct.
What are they? Oh yeah, no, those are. And even
If you haven't traded, make sure each of you gets a chance to talk.
I don't know.
he's got a mic. Mike. Oh, that's his name.
Steve, can you turn me down for a moment? I'm not ready. I was going to just chat over here.
How are things up on Sterling Creek? Dry?
Pretty dry, yeah. And the Douglas firs don't like it. They're just dying.
All right, with that, I'll
In
call
the
you
Applegate Valley.
back, and Okay, so now it's not advancing.
Sorry?
Was it mostly heat stress or bug damage too?
It's a combination. I'm going to talk about it, funnily enough.
Okay.
So I'd like to introduce Alan Journet. I think most of you know Alan. What you may not know is his degrees are in entomology. So he actually studied entomology, and this is his field. He says he got better, but I don't think he really has. So he's going to share with us tonight some ideas about climate change and our friends, our buggy friends. Okay, Alan.
Okay, thank you. I like to compare my experience as an entomologist. Have you seen Monty Python and the Holy Grail? You remember the scene where John Cleese is one of the witnesses as they're trying to decide whether to drown the witch? And you remember that? You don't remember that scene? It's just hysterical. Anyhow, so he says he's trying to indict the witch. And he says, "She turned me into a newt, but I got better." And so I think that's my story. I was an entomologist for a while, but I got better. But Kathy doesn't think I did. Anyway, before I start, I want to acknowledge Christina Lefevre, who's with the Pollinator Project, because they're co-sponsors of this program. And if you haven't seen, Christina has brought a wonderful array of material back there for you to look at. I am not going to stand here because I like to cheat and watch my slides from back here. So I use this as my script. Okay, so when we think of bugs, those of us who are not in the bug academic arena think of a whole array of things, and I've put a few examples, and I'm going to talk about these guys as we're going through the presentation. So bugs, let's start with what bugs are. It's a general term, and it's kind of used for any kind of insect or similar creepy crawly or slimy invertebrate organism without a backbone, worms and so forth. We'll talk about that in a moment. Most people think of pretty much all insects as bugs, plus these things, nematodes and so forth. But we also, when we're thinking bug, you got a bug, then we're thinking of bacteria and viruses. And these all fall into the arena of what I am going to be talking about today. So, I am an entomologist, a recovering entomologist. When I was a graduate student, these were the only things that were true bugs, and you can tell these guys because if you look at them, things like stink bugs, if you look at them, you can see this little V shape at the back of the abdomen, and these are the wings. This is the hard part of the wing, and this is the soft part, and there's a little line here which separates the hard part and the soft part. So those, when I was a graduate student, were the only things that were called really true bugs. It's the order Heteroptera. But I was amazed a couple of years back because I was looking this up, and some taxonomists are always shoveling things around, and suddenly all these other insects got lumped into the true bug category. So these are aphids, cicadas, leafhoppers, and this little thing it's a psyllid. It's a kind of leafhopper that my PhD was on, insects like that, but who cares? Okay, this is going to be the outline of my talk. I'm going to talk about how temperature influences cold-blooded organisms, and talk about how that impacts range shift, which is the focus of why I got into this. The executive director said, how about we have a program on why diseases are moving north? And he looked at me and said, well, you're sort of an entomologist, you should do that. So, and I'm going to talk about insect-eating migratory birds, diseases and agricultural forestry pests, particularly bark beetles and disease carriers, talk a bit about monarchs and other pollinators, and when I get down to starting to talk about carbon dioxide, you'll know I'm pretty much close to the end. Okay, I want to start with a little I hope it's painless, animal physiology. And so if this is painless, scream at me. What we're going to do is look at what's called a...
If it's painful.
It's painful, yeah. I hope it's painless. If it's
painless, we won't be screaming.
no, if it's painful, scream. Thank you. Thank you, Warren, for the correction. We're going to look at what's called the physiological or ecological tolerance curve of organisms. I'm going to look at two kinds of, I'm not going to spend time on the warm-blooded guys. I'm going to focus on the cold-bloods. Organisms have an array of environmental conditions that influence them, and we'll talk about that. I want you to imagine you are a northern bobwhite. Now, if you don't know what a northern bobwhite is, that's it. Okay, so you're a northern bobwhite. They tell us, you know, when we're talking, we should make things like in stories, and so you're a northern bobwhite. So this is your physiological tolerance curve. We're going to look at this. So imagine that there are various environmental conditions that influence you as a northern bobwhite. It could be the temperature, it could be salinity, it could be soil moisture. If you're a plant, it could be particularly soil moisture. And imagine how that, as that condition varies, think temperature. It's the easiest one since it's basically the focus of my presentation today. Think temperature and think of how you as an organism respond to variation in temperature, from low on the left, low temperature on the left, to high on the right. So we're looking at the health, the growth rate, and the reproductive activity of you as a northern bobwhite. So here's your curve, and there's going to be a point where the temperature is most appropriate for you as a northern bobwhite, where you are at your greatest fitness. That's the optimum temperature for you as a northern bobwhite. As the temperature drifts away from that, your fitness drops. So you're not as well able to reproduce as you were in the optimum, but you're probably able to grow as temperature gets above or below that optimum. And if it goes further out, you're probably not able to grow, but you are able to survive. And if it goes outside of those conditions, you're in your zone of temperature intolerance. Now, if somebody wanted to find northern bobwhites, you and your family, what they would do is go where the temperature is optimum for you as a northern bobwhite. And so that's where the population density of northern bobwhites, you and your buddies, is the highest in that optimum range. Now, if you can measure every environmental condition that is critical to the northern bobwhite, what you have done is described what is called the ecological niche of the northern bobwhite. That's what we mean by an ecological niche. So that's the basic principle of how temperature influences organisms. Now, different organisms respond differently to variations in temperature. And they respond differently, and the response of organisms is a function of the fact that the biochemical reactions that drive you as a living northern bobwhite are temperature dependent. Organisms have different kinds of relationships in terms of temperature. There are ectotherms, and they are organisms that obtain their heat from the environment in which they live. And these are what we call cold-blooded animals, like worms, snails, insects, shrimps, and lobsters, and that's why the title of this talk is In Cold Blood. Now, it's also Plants are also ectotherms, but you know, I don't know what to call, what do we call them? Cold tissued or cold phloemed, but cold blood works for all of these things, I guess, is easier to term. The other group of organisms that aren't ectotherms are endotherms, and we are endotherms, and so are birds. So these are organisms that generate their own heat from the metabolic processes of the body. So we generate our own heat. Ectotherms don't generate heat from the biochemical reactions in the body. They rely on the environment. So let's look at how cold-blooded critters are temperature dependent. We're going to start with the ambient temperature and how that influences the body temperature of the organism, and then how that, in turn, the body temperature, influences the metabolic rate in the biochemical reactions of the organism. So there's the ambient temperature on the horizontal axis. There's the body temperature, and how does the ambient temperature influence the body temperature? It's pretty straightforward. As the ambient temperature increases, the body temperature increases. And that's what is driving the biochemical reactions of an ectotherm, a cold-blooded critter. Now, how does the body temperature in turn influence the metabolic rate of the organism? Well, as the body temperature rises, the metabolic rate rises. So essentially we have a curve like that. However, the metabolic reactions inside cells and organisms are driven by enzymes, which are protein. And if that protein gets too hot, it gets cooked, just like a steak does on the grill. And so as the temperature gets too hot, the metabolic rate doesn't just keep going up, it just stops because the organism is basically fried. So it drops very quickly. And it's usually a curve a little like that, so that the temperature, as the temperature rises, metabolic rate increases, and then to an optimum, and after that it suddenly drops very, very quickly. Now let's imagine how that impacts an organism that is an ectotherm, a cabbage white caterpillar, for example. So here's our cabbage white caterpillar. There's the actual butterfly, and they're kind of pretty little things, but we don't like them if we are trying to grow crops, because they are the big munchers of our cabbages and beans and things. So here's what happens to the development of the cabbage white caterpillar as the temperature increases. And what we're doing is measuring the percentage of development per day as the temperature increases. And just like the curve we looked at a moment ago, as the temperature increases, the percentage of development per day increases. So if the temperature were high and the organism weren't being fried, it would develop in one day. But that would be too hot, and the enzymes would be fried. So we see this kind of a curve, and as I depicted a moment ago, if the temperature gets too hot, all those enzymes in there are fried, and the caterpillar is died. So that's how temperature influences ectotherms. And the ectotherms, remember, are not just the insects, but the lobsters, the crustaceans, the shrimp, and nematodes, and viruses, and bacteria. All of those things are temperature dependent, and this kind of a curve applies to their development rate. So the point is, out there in the real world, these organisms are limited in their distribution by where it's too hot or not hot enough. And this is the distribution of the yellow birch, another one of those cold-blooded organisms, a plant, obviously. And up here, there are too few warm days in the year for the yellow birch to survive. Down here it's just too damn hot. And so this is what determines where you will find yellow birch. And ectotherms, cold-blooded organisms, are going to be controlled in essentially the same way. There's going to be a northern limit to their distribution where it's just not warm enough for them to develop, and there's going to be a southern limit where it's just too hot for them. Okay? So for all cold-blooded critters, development, the same principles apply. But for many plants and animals, as you will probably appreciate, average temperature may be less critical than certain seasonal extremes. And I'll illustrate that with reference to the famous saguaro cactus that lives in the Sonoran Desert. The northern limit to the distribution of this cactus is where a day occurs where the frozen temperature during the winter doesn't thaw out. So if there's no thawing, then the saguaro can't exist. It can survive a night of frozen temperature, but it can't exist if the next day doesn't thaw out. So that's the basic point. That limits the distribution of the saguaro. So it's not an average temperature that limits it, it's this extreme condition. This species, incidentally, is a keynote species, and what that means, it's a very important species in the ecosystem. If you are in an area where you're seeing saguaros, you are in the Sonoran Desert. The northern limit of the Sonoran Desert is where the saguaro no longer exists because it's too cold. Herptiles is a generic term for, not for herpes, but for reptiles and amphibians. They have a temperature response which is similar to, exactly parallel to what I've just been talking about. It's not a nice neat curve, and I've mentioned that in relation to that caterpillar development. It's actually shifted to the right. So the activity range for amphibians and reptiles is it's not just a nice neat curve. It's shifted to the right. As you can see, the activity range is up towards the warmer end of their temperature tolerance. So that's their activity range. Cold-blooded animals like reptiles and amphibians can modify their body temperature behaviorally. And I'll illustrate that with a couple of examples. This is a goanna, which is a kind of monitor lizard. This rascal looks like a cute little lizard, but it's actually 6 feet long, has incredibly long claws, and they have the habit of climbing the nearest tall object if they get frightened. And if it happens to be a human being, they climb that human being and disembowel them.
Oh.
They actually do kill a few people in Australia every year by doing that. But this guy is sitting on the top of a tree. My wife and I were camping at the time, and we woke up in the morning and this guy was just sitting above us. Pretty quickly he warmed up and called off, "Hey, Paul."
Does he live any place other than Australia?
No, except in zoos, I guess, around the world, but no, it's native to Australia, and that's it, this particular lizard. This illustrates a Chihuahua desert whiptail lizard, and you can see right here, he's lifting its back right leg. And that's a behavior that takes the back right leg off the ground so it doesn't get too hot. And if you sit and watch one of these whiptails, you'll see they'll sequentially raise a leg after one leg after another. So they have the capacity to monitor, to adjust their temperature by doing that. Of course, out in the desert, they also have the capacity to go and hide under a tree or under a rock, so they can move around and get out of the heat. So they have the capacity to adjust their temperature behaviorally. The bullfrog, of course, what they can do is just hop in the water if they get too hot. So they also have a behavioral capacity. I have a long story that I could tell you about this rattlesnake, and I won't because it takes too long. So the rattlesnake is another one of these ectotherms, cold-blooded organisms, and here's poison ivy, which again is cold-blooded. So what happens to these organisms is what I'm about to describe incorporates fish, insects, crustaceans, snails, worms, fungi, bacteria, and viruses. All of these cold-blooded organisms have the following behavior. As the planet warms, they develop faster, and they can therefore expand or adjust their geographic range. And what they tend to do, not surprisingly, this is the mosquito. I call this photograph The Last Supper because it was on my knee. And that was the end of that mosquito. So what's happening is, very simply, these organisms are able to exhibit range shift, and in the northern hemisphere, not surprisingly, they are tending to shift their range north as the temperature warms up. And that's basically the driving principle behind what I'm going to be talking about for the rest of the presentation. They also can adjust their range to higher elevations. Interestingly, when Nairobi was first established, it was above the range of the malarial mosquito, but the malarial mosquito has now risen to Nairobi. So it worked for a while, but climate change is having the impact of allowing organisms to rise up mountains and move north. Another thing that influences particularly insects is their water balance. They are water is a critical component in the environment of these insects. They get water from their food, from drinking, and from metabolic breakdown of food that they eat. And they lose it through secretions to the atmosphere and excretion. So they're very sensitive to water in their environment and humidity. And insects have these holes a bit like stomata in plants. They're called spiracles, and that's how the insects get oxygen into the tissue, comes in through those spiracles. Just as in plants with the stomata, which allow carbon dioxide entry and water to exit, insects lose water as oxygen enters their body through these spiracles. So they are very sensitive to the southern end of the range. As the temperature rises and drought picks up, insects and ectotherms are limited at the southern end of their range. And so what tends to be happening as we warm up is the whole range of these, geographic range of these species tends to shift in the northern hemisphere north or up in elevation. Let's shift to a little discussion of migratory birds and the caterpillars. What we're looking at here is the historic peak arrival. Okay, this is the arrival point of migratory birds into North America. And a little later, after they arrive, what they do, not surprisingly, since they came here to do it, is they nest, and then they have a clutch of eggs, and that's depicted here. The old peak hatching time for the bird's eggs was around June the 3rd. Now, what was convenient for them, which is what this is all about really, is that also was the peak caterpillar season. So what they're doing, historically they've been doing, is coming here, produce their eggs, and they have a mass of caterpillars to feed the chicks. Unfortunately, as I have just been describing the process, what's happening is, as we have experienced global warming, the rate of development of those caterpillars is speeding up. And so that peak caterpillar season is shifting forward earlier in the year. Now, the birds can respond, but nowhere near as rapidly as the caterpillars speeding up of development responds. So they do have the capacity to shift their arrival time and clutch forming time earlier, and birds are tending to do that, but not as rapidly as the caterpillar speed up is happening. So we get a situation like this. So now what's been happening is the new peak caterpillar season, as you can see, is a couple of weeks earlier, if not more. And the peak bird hatching season shifted a little, but it's not keeping up with the caterpillars. And so now what's been happening across the world of migratory birds is they haven't adjusted their their arrival very much, because that's driven by the length of day and night, the photoperiod. Birds don't migrate in response to temperature. They migrate in response to the relative length of day and night where they are at the time. So that doesn't change. Global warming doesn't change that. It does change the caterpillar's development rate, and the birds have a limited capacity to exhibit change in their clutch timing. So they're kind of trying, if you like, to catch up with the caterpillars, but they're not quite as successful as the temperature has impacted the caterpillar growth rate.
So what other food do they get besides the caterpillar?
Well, other insects they would eat, but whatever else is out there. But the other insects are going to be responding exactly the same way. So as far as their food matter is concerned, they are up a creek, yeah, basically. Another problem that we are aware of is the bark beetle problem, and I'll talk about this one. This is a photograph that I took when Kathy and I were on a trip out to visit one of our daughters in Colorado. This is in Steamboat Springs. And what you can see here is a whole bunch of these are lodgepole pines. And you can tell that they didn't die from fire because they're not black. So these are up at about 8,000 or 9,000 feet. And here's another photograph, the same thing. So these have been whacked off by bark beetles, basically. So millions of acres of conifers are dying as a result of increased problems from bark beetles, particularly. What used to happen in the old days was over winter, the conditions got so cold that most of the population of the bark beetles that was there overwintering basically got whacked off by the cold winters. They got frozen. But as winters are getting less and less frigid, more and more of those beetle larvae are surviving the winter. So the population starts in the spring even higher than it used to be. And then because the springs are coming earlier and are warmer, again we get this problem that the development rate of the larvae increases. So the population of the bark beetles picks up much more rapidly in spring and through summer because of the increased temperature. And then we have another little problem that's happening, and if you are a bark beetle, this is to your favor. This is the life cycle of the bark beetle. This is the beetle itself. The beetle itself does no damage. It's the larvae that live under the bark of the tree and basically eat out the tissue of the tree and kill the tree if there are too many of them. Herbivorous insects, insects that feed on plants, have an essential problem. Nitrogen is a critical component of the protein and DNA in the cells of all organisms. In plant tissue, the nitrogen content is on average about 3 or 4%. It's relatively low. But for insects, that nitrogen concentration is about 10%. So herbivorous insects have a nitrogen problem. They are constantly struggling to get enough nitrogen out of the plant matter that they're eating to build their tissues. Trees have a physiological response to drought. And this physiological response that they have to drought reduces the rate at which water is lost from the trees through transpiration. What they do is they mobilize the protein that's in their tissues and convert it into its constituent amino acids. The protein is the nitrogen that the insects are, if you like, struggling to acquire. The amino acids are a much more nutritious source of nitrogen for the insects. So what's happening is that the increased amino acid concentration in the tissue of the plant increases its osmotic pressure, and that resists water loss. So this is a great effort on the part of plants to resist drought. Unfortunately, what that's doing is making that plant tissue much more nutritious for the insects. So we get what I call a double or triple whammy. So the warming climate increases the growth rate of the larval bog beetles. The droughts then cause the tree tissue to become more nutritious, and the population increase of the bark beetles is even more accelerated. So that sequence of events is great for the bark beetles, and that's why we have experiencing a substantial amount of Douglas fir decline, particularly in the Applegate Valley. And this is a photograph which I've taken from around where we live. You can see all these orange leaves on the Douglas firs. These trees are toast. Basically, they're dying.
Now, Alan, you are going to give us some good news about what we can do to stop all this, right?
To stop all this, well, what we have, the good news, the question was, Erica wants to know what the good news is. What we have to do, I got asked exactly that question today when I was on Jefferson Exchange. What we have to do is stop global warming. That's what we have to do. I mean, we can adapt to it, and one of the things that foresters are doing is removing the dying trees to remove the bark beetles. This is a flat-headed fir borer. This is one of the little rascals that's causing the Douglas fir problem. It's called a flathead because you can see this is the head. This thing is this whole thing is less than a centimeter long. So these larvae are very small, but do a lot of damage. In fact, they're doing such a great deal of damage to the Douglas firs that we're losing Douglas firs below 3,500 feet, particularly in the Applegate Valley. A word about insect-borne disease, and I'm going to talk about several diseases. The malarial mosquito, which is a member of the genus Anopheles, the limitation for malaria, it's an actual single-celled protozoan parasite. This cannot complete its full growth cycle below 20 degrees centigrade. And so you can readily imagine that as the temperature rises, both the mosquito and the parasite, protozoan parasite itself, are able to exist in more northerly locations. So the range of the mosquito and its parasite are shifting north. The mosquito and parasite can survive now at higher altitudes and latitudes, and I mentioned that in relation to Nairobi a moment ago. So this is what's happening to the distribution of the malarial parasite, the malarial agent, the mosquito. Historically, in the orange, by 2050, it's expected that the mosquito and the parasite can exist much further north and much further south. So this is what, it's all this temperature pattern that's allowing the disease to exhibit range shift north, south, and up in elevation. West Nile virus, it's another mosquito. Warmer conditions enhance the growth. However, if it gets too hot, it kills them. And so this global warming is causing the climate appropriate for the West Nile virus mosquito, just in whole part, to shift north. They require moisture for life cycle completion. So at the southern end where things are drying out, they're getting eliminated. Now, Aedes aegypti is another mosquito, and that's exhibiting exactly the same pattern. It's tending to shift north and south from the equator. Lyme disease is called by a little rascal which is known as a spirochete, and this is the spirochete that's causing the problem. And these are the ticks, the black-legged deer ticks, that are the vector, the carrier of that disease. And this is what's happening in Lyme's disease over the period 1988 to 2016. You can see a consistent general increase in Lyme disease in Oregon. Again, it's a climatic shift of the tick and the disease north. This is a condition that I only just heard about a week or so back when I started pulling this talk together. There's this thing you might have heard of called an alpha-gal syndrome. It's a life-threatening meat allergy caused by tick bites. Was first linked to a particular species of tick about 15 years ago, as it turns out. It occurs when the human immune system triggers an allergic response to a type of sugar found in the meat, and it's known as an alpha-gal. Rising cases reflect the expanding range of the Lone Star tick from Texas. Thank you, Texas. It's moving north, and it's up as far as the Great Lakes. Did you want that one? You want to take that one again? Okay, this general trend in the migration, it's not really a migration. When we talk about migration, I'm going to talk about butterflies in a moment. Migration is when a species relocates seasonally and back. So birds migrate to south and back north in the summer. This range adjustment that I'm talking about, range shift, it's not really a migration, because it's not that they're moving north and then they're going to move south again. It's a permanent geographic range shift. People call it a migration, but it really isn't. So what's happening is viruses, nematodes, insects, and fungi are moving from the equator north and south at the rate, on average, of about 3 kilometers a year because of global warming. Let's visit the monarch. This is a monarch. We actually haven't seen monarch this year in our lot. We have a mass of milkweeds. Paula was telling me he saw one in his garden the other day. We haven't seen any this year. this milkweed is, this monarch, incidentally, is not on milkweed, it's on fennel, flowering in our backyard. About 3 years ago I took this rascal. You're probably familiar with these are actual migrations. They migrate north. It's not the same butterfly coming north that goes south. It's several generations later. They go through several generations up here, and then few generations later, when it comes back to winter again, they migrate back south. So there are essentially two kind of migratory populations of monarchs. There's the western rascals with which we're familiar here that go down into California, and then the ones through most of North America, which go up as far as Canada, go back down and go down in the winter down into way down in Mexico. So what tends to be happening with the monarchs, and this is what's the climatic impact, what's happening is they've declined about 95% in the last 20 years. Every year a new generation of these butterflies follows the same path forged by generations before them. The only thing guiding them on this migration is temperature. So it's temperature that is the trigger that alerts the monarchs that hey, when you're down in Mexico, it's time to go north, or if you're in Canada, it's time to go south. In recent years, monarchs, their full southerly migration from the northern end of the range has been delayed by as much as 6 weeks because the temperature is warmer. However, what's happening is, as they are now migrating south, they get whacked off because they get killed by the cold temperatures en route to the winter range. So that's one of the things that's impacting monarchs, but that's not probably the major thing. A bigger problem for monarch butterflies is our use of weed killers like Roundup that eliminate the milkweeds on which they are dependent. So there are other butterflies which are exhibiting similar responses. This is a butterfly called Edith's checker spot butterfly, Euphydrius editha. And there's been an immense number of studies that have been conducted on this particular butterfly. It has very limited mobility, so its range, its potential to exhibit range shift is very limited. And so they seem to be going extinct in the southern end of their range, but they're doing much better in the northern end of their range. Same pattern is happening in relation to low elevations and high elevations. We have a local Euphydrius, probably several local species. This is one that a photograph I took of what I think I identified as Euphydrius anicea. This is a local version, and this one's on dogbane. So the larvae develop and it feeds on dogbane, and there's the dogbane. So we have local Euphydrius that are subject to the same problems as Euphydrius editha. And another point to note for all herbivores, if the host plant range exhibits a shift, then that becomes a threat to the insects or whatever themselves. 80% of our food plants worldwide depend on pollination. And if you want to learn more about pollination, talk to Christina and visit the Pollinator Project Rogue Valley folks. We plant crops where the climate is appropriate for the crops, not surprisingly. But we also plant crops where the soil type is appropriate. Now, climate shifts, but soil type doesn't. the soils are somewhat static and immobile, so they can't just kind of shift in relation to global warming. So pollinator range shift induced by global warming can shift pollinator distribution away from the crops that we plant that rely on the pollinators. Solitary bees, for example, live only a few weeks, so a very short period of heat or drought can really assault their populations to a catastrophic extent. There are other assaults that are resulting from carbon dioxide. The increasing atmospheric carbon dioxide, among other greenhouse gases, methane and nitrous oxide, is causing global warming. We know that. And the climate change consequences. While carbon dioxide does drive photosynthesis and can stimulate plant growth, we hear a lot about how, hey, carbon dioxide is great for plants, great for agriculture. But there are costs. One of the consequences of increased carbon dioxide is plant tissues become less nutritious. And I'll show you an example of that in a moment. And the protein concentration in pollen drops, which threatens bee populations. So here's the sequence. Elevated carbon dioxide lowers the quality of food for insects. And here's an example of a caterpillar. Lower insect growth rate, you might say, well, that's great. Isn't that wonderful for agriculture? Well, unfortunately, the response that the insects have is to eat more, which results in increased damage, reduced yield, and/or increased pesticide use. And this is an illustration of how increased carbon dioxide, up to about 550 parts per million, experimentally reduces the nutritional concentration of plants. You can see in the case of wheat, zinc, iron, and protein concentration in the plants have dropped. And phytate is a compound in the plant which sabotages our ability to uptake zinc. So if the phytate composition goes down, that's okay, but when in some situations the phytate composition is going up as the nutritional composition is going down. So when you hear folks talking about, as they often do, how wonderful increased carbon dioxide concentration in the atmosphere is for agriculture and vegetation, what they're doing is totally ignoring the fact that it's compromising the nutritional quality of our food. Rising carbon dioxide levels causes bee die-off. I talked about that a moment ago. The tests of the pollen content from goldenrod over the period 1842 to 2014 show a considerable drop in the pollen, the protein content of the pollen, with a really negative impact on the bees, which rely on that pollen. Goldenrod is one of the key critical late season food sources for bees. So as we reduce the protein concentration of the goldenrod, we're compromising the bee populations. Okay, so I've gone a bit beyond so I will pause and invite any questions if anybody has any. I'm passing the.
I'll just make a comment on.
Go for it.
Considering the topic, the goldenrod is hardly a late season anymore. It's in full bloom right now, and I'm not sure if the end of July is a late season or not.
I think but that trend is happening for a lot of plant species. Just as the insect development is speeding up, so plant species are developing faster, and we're getting into flowering season earlier.
Oh, do you want me to repeat that?
No, that's all.
Oh, no.
Thanks, Christina. Steve.
So, I mean, most of us have seen fall-offs in our area, both birds and insects. Most of us have seen a fall-off of both insects and bird migration in our area. To what extent? I mean, is somebody tracking the decrease in local bird populations and insect populations in this
I
area?
imagine so. I have heard that certainly insects are being dramatically impacted by global warming. It's interesting that you should mention that, because Kathy and I have been noticing this year we have seen way more grosbeak babies and robin babies than we've ever seen. So that just.
That is interesting. There are more robins in our neighborhood than there have been in the
Yeah.
past few years. So.
Oh, no, sorry, she.
Erica.
Yes, so I would like to hear how this is impacting the human population. More disease and less nutrition in food, and what's going to happen to us?
Well, yes, the answer is yes. We are experiencing, as carbon dioxide concentration increases, that is having a negative impact on a lot of food quality. What was the other part of the question?
Well, our health. I mean, what about our
Well, yeah, and all of those diseases are shifting
Yeah.
into our range from, tropical diseases are moving north and south.
Well, I don't see us adjusting to any of this.
Well, I don't see us adjusting very much except getting sicker.
Yeah. So what are we expecting? Just more people to die sooner or to more?
I suspect that things like malaria will become a much bigger problem through much of the United States.
Alan, wasn't West Nile just found in, where was it, White City or Central Point here?
I think I read about that. What is it, the first time? Yeah, and the those Lyme disease ticks, that's already here. Yeah, Christina.
Oh, I was actually going to hand you the mic, but then I realized you have a mic.
I do.
I had a question or a comment about the birds. There are a number of organizations, obviously, that are tracking birds, like Cornell, and then we have the Klamath Bird Observatory locally. But I just wanted to mention that caterpillars are extremely important for baby birds, because I've learned from Dr. Doug Tallamy that the caterpillars are just full of protein and they're very soft, and so baby birds need caterpillars, and that's the best thing for them to eat. And what do caterpillars eat, other than maybe the cabbage white butterfly that goes in your broccoli? Most of them are going to be eating native plants.
Right.
And that could be either the goldenrod, it could be an oak tree, it could be a willow tree. And so many of our local ecosystems in this country are not full of native plants. They're full of agriculture, monocrops, they're full of buildings, they're full of concrete. And so one of the things that Pollinator Project Rogue Valley is really encouraging people to do is look at the percentages of native plants in their yards. And so the more native plants, including grasses, then the more caterpillars hopefully you can have, because you have more butterflies and moths, and that's going to help feed the birds. There's so many aspects to it, though, and having the heat rising, impacting the caterpillars, so you're not going to have butterflies and moths to lay more eggs because either there's not enough food or it's gotten too hot. And then the only other thing I wanted to point out, which is really not off topic, except that it is not talking about insects. So if you are in your nice, cool room like we are right now, it's all wonderful. And then if you go stand outside beside your air conditioning unit outside, then it's a very easy thing to understand why we have global warming.
Yes, I mentioned in relation to the monarch, of course, that probably the greatest threat to the monarchs is probably less the global warming than our use of insecticides, which is eliminating the milkweeds. And that's the same is true for all the other different species of caterpillars, butterflies and caterpillars out there. Yeah.
Any other questions?
All comments?
Well, I'd like to go back to Erica's question earlier about, this is all bad news. What are we going to do? Well, the good news is we're causing it, so we can do something about it. It's not easy to do that, but that points that we have control of things because we've messed it up. So this is not an example of what we can do a little Band-Aid on. This is getting at the real heart of the global warming, the climate change. And that takes some pretty heavy-duty work, but there's the challenge, is what are we going to do? And it's little steps that we can take, but there's a challenge to what we do.
The challenge too is to get the right people to listen
Yes.
and do
Yeah.
something about it.
Yeah, get the right people to listen.
I don't see there a lot of progress in that vein.
I don't see enough progress by any stretch of the imagination. This whole subject, because my background is in ecology, teaching all of this stuff is what really energized my concern about the whole global warming climate change issue. And I think probably if you talk to ecologists, they are probably amongst the group of people who are the most concerned about the impact of global warming, precisely for these reasons. It's not that there's some easy fix to these individual problems, and when folks are talking about, so what can we do about the bark beetles, my response is, we have to address global warming, because that's the root cause of the bark beetle problem we're having. Everything else is Band-Aid.
Well, thank you, Alan, for sharing. Thank you. So my task is to share some things that are coming up, let you know. And a lot of this is increasing your knowledge, but also trying to give you opportunities for action and encourage you to take action. Our next meeting, this is not confirmed yet, but we think that we have a discussion about the climate protection program, which has been in place, and cap and trade. So these are the discussions now. What's the best thing for us to do? And we're hoping to get some people sharing knowledge about options. And so that's our plan for next month. We did want to take a moment to thank people that joined us at the 4th of July. We had people in the parade and people working at the booth. Maybe just raise your hands if you were one of those people who were there walking or helping out. So thanks to everybody who joined us at that event. We encourage you, if you're on social media, to follow us and to like and share the posts. It really helps get the word out. Things we feel right now are not happening. Well, this is one way we can help things happen, is SOCAN's trying to put on their social media information that people can rely on, and if you share it, then it helps spread that information. One of the groups we have is the Federal and State Project, and this group is working on the candidate forum, which will be on October 13th. It'll be here from 6 to 8 p.m. If you're interested in helping with the planning of this event, there's a flyer back there that tells you who's going to come to answer questions about climate and the environment. If you want to help in the planning, let Alan know. If you want to just help during that day of the event, that evening, we'll need people for helping. So let us know. And mark your calendars, October 13th. We have received a grant to work in the education area, to work with teachers, and we're very excited to finally get funding for this. It's called Youth in Schools Climate Education, and what we're doing, we're just starting on this, is we're going to identify 2 teachers in each of the counties, Jackson, Josephine, and Curry. And those will be our lead teachers. And then as we go on, we'll have activities where those teachers will develop lesson plans that they can use in their classrooms. They'll teach them, we'll watch them, and offer ideas to encourage student learning, and then we'll expand it to other teachers. So we're right now looking for our 6 lead teachers. So if you know any teachers, it can be K-12. They can teach any subject as long as they're interested in incorporating something about climate change. So an English teacher can do it, and as the topic that the students are writing about reflects climate change. So it can be any grade level, any subject. So let me know if you know any teachers who might be interested. Living with Climate Change Rogue Valley. This is the 10-week course. Used to be Master Climate Protector. We're alternating now between OLLI 1 year, that was last year, and SOU. So this year in the fall, starts September, that's supposed to be the 23rd. September 23rd is going to be the first class. And it'll be SOU students, but we also have permission to have community members involved. And it's a different dynamic when you're doing a discussion, having older and younger people. And it really makes a good conversation. So consider if you're interested in committing 10 weeks. So it's a big commitment, but it's an understanding of different issues about climate change and how it affects like energy and agriculture and transportation. And we have some graduates of the classes in here. You want to raise your hand if you've been through okay, so we got some people if you're interested in talking to them about what it's about. And there's flyers on the back table, I think, about that one. We realized we haven't at these meetings said much about our monthly newsletters, and so we encourage, if you're not getting those, to sign up to get them. If you put your name on the list in the back, I'll add you, or you can go to the website, and towards the bottom there's a place where you can sign up. So we're trying to do different information about climate change, as well as events that we're doing and events that other groups are doing, just to keep you informed. You can always unsubscribe, and the broadcast comes the first of the month. The reminder comes a week before the monthly meeting, and then occasionally there's another one, but we're not going to bombard you every day with emails. Sustaining Climate Activists is a group that meets monthly. On the fourth Saturday, the next meeting is August 22nd, and it's from 10 to 11:30. It's a support group. Anybody's welcome. We have people that are active in SoCan, but people who are not active in SoCan. It's open to anybody, just to help us deal with some of the stress and anxiety that are part of this world. So anybody's welcome to come and join us and see, and if you don't like it, you don't have to come back, and if you do, you're welcome to come back. We're now in Blue Heron Park, so we're outside, which is kind of nice.
So long as the weather's okay.
So long as the
And
yeah.
smoke particularly.
If we always reserve the talent library, so we have a backup if we get smoke or bad weather. And now we're on different events by our partners. Pollinator Project Rogue Valley has pollinator adventures in the park Saturday, August 11th through the 13th in the morning. It's a 3-day program for children, opportunity to explore the world of native plants and pollinators. So this is Christina's if you want to ask her questions, and you get to see the children's learning garden at Blue Heron Park that is new, right? Yeah. Jackson County Library, this is at the Phoenix Library, pollinator garden ribbon cutting, August 20th. And so they have established a pollinator garden there if you want to.
I think that's a Thursday, in case you care. Or they had it wrong and they said Wednesday, but I think it's a Thursday.
And we have it really wrong saying Saturday. Is the 20th right?
It's the 20th.
All right, so it's on the 20th, whatever day of the week that one is. This is Bellevue Grange. They are sponsoring a speaker, Jan Spencer, who's going to talk at the Grange on Friday, August 7th. The focus is on convergence of care for our natural world, urban land use, economics, and permaculture. And so that's available and sponsored by the people at the Bellevue Grange. This is KS Wild, and they do these Defenders Wild Activist Night to get people to do things. This one is on the 30th, which is day after tomorrow, and this one's going to be a virtual webinar about the mining threats in Southern Oregon and what we can do to protect our public lands.
How do you know how we get to attend that?
I would go to KS Wild's
Go to
Facebook.
KS Wild website, okay.
And this is, OSU has a land steward training that they run each year, I believe. This one is September through December, and there's a tuition charge, and you need to register for it. So if you look up OSU Extension, you'll see that. And things I haven't caught, the Rogue Valley Voice has an eco-spiritual calendar, and so if you're interested in other things that are happening, if you go to their, if you just Google Rogue Valley Voice, you'll find it, and they have things that they keep current each month that are happening. All right, on the top, take action. What are you going to do? Okay, you need to think what's within your interests, your abilities, your sphere of action, and there's something for everybody to do, and you're special. So what's it going to be for you? That's really, really one of the most important things we can say. And SOCAN always appreciates your support if that's one way that you can contribute. I wanted to call your attention to these. I put some around on the chairs. There's more on the back table. This was Daniel's idea. We did the SOCAN Sun Volume 1. I have 3 copies left in the back if you didn't get one of that, first edition. And then this is the second volume. These are things written by people in SOCAN or friends of people in SOCAN. Idea being to give people something on paper. Some people really enjoy on paper. Written by people that are concerned about climate issues and generally have a strong science background or science basis for what they're saying. So we just picked these up. Dale just picked these up today. So if you have friends that might be interested, feel free to take extra copies for them and share them. On the first one, we just put them in different locations. So if you have a location you think might like to have a few copies, take them and put them there. I think that's it. I thank you very much for coming tonight. And there's things in the back to look at, and hope you will decide on an action and do it. Okay. Thank you very much.
Put your chairs back. Please, put your chairs back.
Okay, yeah. Alan wants help putting the chairs back.